today with James Logan. James, how are you, sir?
I'm very well, thank you.
Good, good. Listen, let me ask the top line question. One of the most famous things you did was you looked at the impact on parasites on yourself. So you kind of actually put parasites in yourself to study the whole thing. Why would you do that?
So it's a good question. Yeah, I mean, why not? So yes, I did. So look, I'm really, really fascinated by the tiny things in the world because they rule our world. We've just had the COVID pandemic, so we see the sort of impact that these small things can have on all of our lives. So part of my job is to really understand them, get down to their level, see the world through their eyes, essentially. And the only way to do that sometimes is to experience it yourself. So I did this. I basically, it was also part of a TV program that I presented on called Embarrassing Bodies, which was on Channel 4 back in the day. And of course, they loved the idea of, somebody giving themselves worms because it's pretty disgusting, if nothing else. Yeah, I mean, essentially, these worms are fascinating. It was a really good scientific reason to do it. So basically, what you do is you get these worms. So I had a source from the laboratory, nice and sort of clean. And these worms are microscopic; they're absolutely tiny. And in the wild, they sort of are found in soil or in water droplets on plants. And as you walk past vegetation or you walk barefoot in sort of tropical regions of the world, they enter your body through your skin. So they burrow in through the skin. And then what they do when they're in there is they get into the bloodstream. They sort of take a ride through your bloodstream, through your heart, and they end up in your lungs. Then they burrow through your lungs and you develop a cough, and you essentially cough them into your mouth, and then you swallow them. And that's how they get into your intestine. It's not every worm that does this, but this specific type of hookworm does this. But they're microscopic at that stage. Once they're then inside your stomach, they then develop as adults, and they essentially feed on your blood. So they're called hookworm because they've got these big teeth that essentially allow them to attach to the intestine, and then they suck your blood. But that's all quite sort of horror story-ish, isn't it? But there's a really, really good reason for this. So essentially, they are incredible animals because once they're doing that, what they do is they inject a sort of saliva into your bloodstream. And that essentially, first of all, it makes you not be able to feel it, but it also stops the blood from clotting. There's a whole cocktail of chemicals in there, which essentially dampen the immune system. So if you have various conditions like gastrointestinal conditions, Crohn's disease, that sort of thing, these hookworm produce a chemical substance that dampen your immune system so that your immune system doesn't get rid of them. But in doing so, it also prevents the kind of other medical conditions that you can have, even asthma and eczema sort of allergies as well. So they're kind of nature's remedy in a way. They've got this incredible cocktail of chemicals, and some people actually give themselves hookworm to do that. Now, the reason I did it, why did I do it, you said? So I can't eat bread without being really, really ill. And I hadn't had pizza or garlic bread for a very, very long time, two of my favorite foods. I had the worms, and within a few weeks of having the worms, I sat down and I ate a pizza and I ate garlic bread for the first time, and it was beautiful. And I was really lucky to do that. Then, a few days later, lying in bed, my wife kind of went, "I'm sorry, but this is disgusting. You need to get rid of the worms." So, I'm not having any of it. So the worms went, unfortunately. I took a pill, off they went, and a few days later, I couldn't eat bread. So it's a fantastic story, but it's a little bit sad at the same time.
Yes, no. So let me ask, as you're telling the story, the thing that struck me was that how do you feel about our relationship with kind of parasites and kind of as human beings? Kind of that story is like it gives me shudders, and I'm like, but actually, what you're telling us is how amazing they are and how we can use them to our benefit. So does it frustrate you, or does it kind of empower you over the fact that maybe the relationship between humans and the natural world isn't as healthy as it should be?
Yeah, I mean, I have a fascination with the natural world, and when we say the natural world, most people think about big animals, the types of animals we want to conserve around the world, and plants and that sort of thing. But of course, part of our natural world includes parasites and insects and all the kind of bugs that we don't really want to have around. But the truth is, this is a bug's world. It is their planet. We're mere visitors. They were here long before we were, and they're going to be here way long after we've gone as well. For every single one of us, there's something like 500 million of them. So they outnumber us massively. And they are amazing. If you think about an insect as well, insects are like they're incredible. They can do things we can only dream of. I like to think of them as the sort of transformers of the natural world, with sort of bolt-on body parts. Every insect's different, and they have these bolt-on body parts that allow them to do things, whether it's carry 10 times their own weight, or fly at incredible speeds and incredible heights, or survive in really extreme temperatures. And we can learn a lot from nature. And the key actually to living with them, living with bugs and diseases and all that sort of thing, is to respect them and to understand them. We've got to love them in a weird way, to try and understand how better to control them so that we can live smarter in their world.
So taking that on to that kind of, you mentioned COVID before, and you were kind of absolutely at the heart of kind of the investigation into COVID and kind of what happened. I suppose my question to you is, based on what you've just said, is there a positive outcome in the sense of kind of how we look at disease or kind of infections and what's going to go on with ourselves, such that actually we are better prepared for future kind of pandemics, or whether it's pandemics or just kind of illnesses as they come along?
I mean, there have been lots of positives, but one thing about nature is that it's always one step ahead of us. Right. So it always works out a way to get around what we're trying to do. And that's why it's been so difficult to eradicate. There's only one disease that's ever been eradicated, and it's difficult to eradicate diseases. And it's something that we talk about doing, but it's really, really, really hard. And we will never get rid of every disease, and we'll never get rid of every pest or insect or parasite. That's just a fact, and we have to learn to live with that. And live smarter, work out a way to control them. But the hookworm's a great example. There are lots of other examples. A mosquito's proboscis, its mouth part, is so sharp that we can't feel it when it goes into our skin. And so it can be used as a way to design needles for taking blood, for example, or giving injections. Nature often has the answer to many of our problems. And
your job is as much to do with kind of bridging the common person, kind of our understanding and our kind of knowledge. So kind of we get those examples and we can start relating to them. How much is that your job as opposed to being that scientist where we visit you kind of in the lab, injecting yourself with parasites and doing crazy other stuff? What's the balance between the two, and how do you get that right?
Yeah, I mean, it's when you think about a scientist, you think they're exactly that. They're in the lab and they're doing lots of experiments and probably doing things in a secretive way or something, and it's not the case at all. And I've always been a big believer in sharing what we do, essentially, not just in terms of here's a result, isn't that interesting, but actually what do we do as a scientist? What's your life like? What kind of person are you? Are you really this kind of boffin or geek? And I'm not a massive fan of those names, but a scientist's job can be extremely varied, and I think it's really important that we continue to challenge the stereotypes. We need to have more girls interested in science and women in science, and at more senior roles in science. And although we think we might have made a lot of progress, actually, in the last 20 years I've been a scientist, I don't think we have made a lot of progress, actually.
On that basis, kind of, what is it that's stopping us getting more senior female kind of scientists out there?
I think a lot of it is really understanding what the job is about, and knowing that it can be hugely variable. In the time that I've been a scientist, I've been lucky. I've traveled the world. I spent a lot of time out in the field in sub-Saharan Africa in various countries, trekking through the jungle, on tropical beaches, tropical islands, doing doing work, obviously, as well as perhaps sipping the odd cocktail, not during work hours, but. And I've met the Queen, I've met the Prime Minister, been to Downing Street. I've had so many opportunities through being a scientist, as well as getting to go on the telly and talk to people, talk to children in schools. It's not just about being in the lab and doing little experiments. That is an important part of it, obviously, but being a scientist today is much broader than that. And I think it also starts early on as well with young people. So our challenge as scientists is, how do we engage the younger generation at the time at which they're influenced by what they're hearing and seeing? And even when you look at the media, so if you look at films, for example, most antagonists in films tend to be scientists. So film, it's always as a disaster because a scientist leaked a virus, or that sort of thing. And it's rare that the scientist is the person who saves the day. And so I think we could change those views a bit and change people's perception. Then we could have the balance much better.
So let me ask one last question. I suppose we live in an age where technology and science-related technology is everything. Everyone's talking about rate of change technology, stuff like that. Do you see society and I suppose the world of science in the natural world? Do you see it as a time of enlightenment, or do you see us treading water a bit currently?
I think we're on the cusp of something really big, actually, and I think AI is the thing that is going to do that. I think things progress all the time. But think about 100 years ago, a few hundred years ago, when lots of inventions were being created. My ancestor invented the bicycle, for example. It's been a while since we've really had these big world-changing sort of inventions, and I think AI is certainly one of them. We use it in our research, our work that we do. We always say it's where the genius of nature meets artificial intelligence, because what we do is we examine nature. So we are really interested in how insects communicate with each other through smell. So they have the world's best noses, basically, and they can smell patterns of chemicals. So if you have malaria, for example, your body odor changes and you become more attractive to mosquitoes, and they can pick up on the pattern of odor that is associated with a malaria infection, and they find you more attractive than somebody who doesn't have malaria. And so what we do in my lab is we connect microelectrodes to the antenna of the mosquito, which allows us to record the response of the cells in the antenna, which essentially are the nose smelling cells in the antenna, so that we can see what a mosquito is smelling. And in doing that, we've worked out what the smell of malaria is. Wow. And then what we do is we use AI to create odor sensing arrays. So essentially tiny little sensors and algorithms using AI that allow us to be able to detect that pattern of chemicals. It's like a fingerprint, an odor fingerprint. So essentially, we've got a machine now that can do the job of the insect's nose. And what we're doing is we're creating little handheld devices that can detect when you have a malaria infection, or we can detect the presence of a pest like a bed bug, for example, just through odor. And what we're working on now are wearable devices. So putting these sensors into a smartwatch, for example, that could monitor your health, monitor your body odor, and tell you when something's not quite right and alert you so that you can then go and get help. And the key to this is early detection. We can detect malaria, for example, at a very early stage of infection. We can also detect COVID and other infections. So there are huge opportunities there. And that's where we've brought together the genius of nature, as I said, as well as AI and technology that's got faster, cheaper, and more accessible than ever before.
On that, thank you so much for your time today, James. It's a pleasure, as always, to chat.
Very good.